Okay, we're now on page 14. So all the stuff that we had mentioned before, it's all pretty much the same, except now the center is not at 0, but it's at x of 0. So it could be any number that you want it to be. Okay, so we're going to get right into the two examples. Right, so let's go down here. It says to find the interval of convergence and the radius of convergence, so it's the same two instructions. So can you look at the series and be able to tell whether it's a Maclaurin or a Taylor? Yeah, how do you know this is a Taylor? Yeah, see this part right here? This is telling us that this is Taylor. This is a Taylor series. And can you tell me what the center is? 5. At x equals 5. So the way that you can tell where the center is you take whatever is with the x and then taken to that power. You just solve for, set it equal to 0. Right? So I could just say that I have my x minus 5 and set it equal to 0. So then x is equal to 5. So that's how you can tell where that center is. So then in diagram, what we're looking at is, if I look at the above case, this right here is when x sub 0 is equal to 5. So now I want to know from 5, how far to the right and to the left am I going, and that's the interval that I'm looking at. Right? And then whatever that distance is, it's going to be the same on either side. Okay, so then I have p equals, this is going to be the limit a sub k plus 1 all over a sub k, absolute value, as k approaches infinity. Okay, so now I'm just going to put in everything on this. So it's the limit. So this will be, so all I'm changing is the k. X minus 5 just stays as it is, so it's the absolute value. X minus 5 raised to the k plus 1. And then the denominator, k plus 1 raised to the second power. Reciprocate, so that will be k squared up on top, and a x minus 5 to the k power. Absolute value. As k approaches infinity. Alright, I think I have a lot of work to do on this, so I'm going to try to squeeze this next line in here. So it's the limit as k approaches infinity, and now I need to rewrite all of this. How can you rewrite this x minus 5 raised to the k plus 1? So it's just like having a base of anything. So it's just this to the k power, and then this raised to the first power. So that'll be x minus 5 raised to the k power, and x minus 5 just raised to the first power, and then I have my k squared. And then the denominator, I'm just going to move this over. So it's x minus 5 to the k power, and this one will just stay k plus 1 to the second power. Okay, absolute value. All right, now I'll cancel what I need to. So cancel, cancel, and I think that's all I can cancel. All right, so what can I pull out that is not affected by k? X minus 5. All right, so then this x minus 5 in absolute value, make sure you have that still in absolute value, x minus 5, and then what gets left is the limit, and then I have k squared over k plus 1 quantity squared as k approaches infinity. So now you're evaluating this portion right here. 1. Okay, so that is equal to 1. So then my p-value is x minus 5. Force it to converge. Less than 1. Okay, the absolute value is already isolated. Right, so now I can make a split. So then it'll be either negative 1 less than x minus 5 is less than 1. Right? So going from this step to this step, you have to make sure that you isolate the absolute value. So if there's either something multiplied or divided, you have to make sure you bring it over to the other side. Right? That's a very important point on that. Okay, now I'm going to solve for x. So get x by itself in the middle. So then this one you'll be doing adding 5, so that'll give me 4. And then subtract, or adding 5 on this side, that'll give me 6. So back up to my diagram here, what I have is 6 here and 4 here. This is the region that's very good. Right? And now my question is, do I include the 4 and also do I include the 6? Okay, so that's where you have to do the endpoints. Okay, endpoints. So the first endpoint is where x is equal to negative 4, or x is equal to 4. X equals positive 4. So I'm putting it back up here. So what is that? Negative 1 to the k over k squared. You could just use this test. Absolutely converges. So this is, and I could just say converges. Okay, so it just converges, and it's by the p-series, or the poly test, whichever. So this is where p is greater than 1, therefore it converges. Okay, so that's our first part. And then the second part of this would be where x is equal to 6. So then if you put in 6, it'll be, the alternator just goes away. So it's just going to be 1 over k squared. And that's pretty much what we have here. So this is also, I'll say poly test. Or you could use the same one on that. So then you end up with, that also converges. All right, so now my conclusion, I'll write it up here. So the interval of convergence would be, including the endpoints, so that'll be 4 less than or equal to x is less than or equal to 6. What's the radius of convergence? Yeah, so for that one, you can't really look at either of these numbers. Look at this right here, and if the absolute value is all by itself, this right here is going to be the radius, right, this number right here. Okay, so this is going to be the radius, and so that will be equal to 1. Okay. Yes, go ahead. Yes. Either way, so I didn't give another alternative. You could also say or bracket 4 to 6. Yep. They'll accept any kind of notation. So those two are equivalent as long as you have it as a bracket. Okay, any questions on that? Okay, I'm going to now pause the video so that you can try B.